Okay, for the first question, tossing four coins, we want to know what the sample space is for that. So if you can get heads on the first one or tails on the second, and this continues. So if you toss the coin twice, then it's going to be 4 outcomes possible. Toss the coin a third time, and now you see that there's going to be 8 outcomes. So that'll be times 2, which is 8. And if you toss it a fourth time, for every one of these 8 outcomes, there's going to be 2 outcomes. So that's going to be a total of 2 to the 4, which is 16 outcomes. Now, tossing a pair of dice, for each outcome, for each die, there is 6 outcomes. So that means that there's going to be a total of 6 times 6, or 6 squared, because we're tossing 2 dice, which is 36 outcomes. And you can see that we've got a 6 by 6 grid of all the possible outcomes when you throw 2 dice. And so if you're going to toss 3 dice, then it would be 6 to the 3, which would be 216 possible outcomes. Now, determine the theoretical probability of tossing 2 heads with 2 coins. So, again, first coin you can get head or tails. So then the probability of that getting 2 heads, there is 1 outcome. Out of 4 possible outcomes, so it's 1/4. Now, rolling a 2 or a 5 with 1 die, well, there's 2 ways you can do that. And when you roll a die, there are 6 possible outcomes. So the probability of that is 1/3. For empirical probability, so if you roll a die 20 times and 4 came up 5 times, well, then the empirical probability, or the experimental probability, is 5 out of 20, which is 1/4. And the theoretical probability of rolling a 4 with a die would be, there is 1 outcome, 1 favorable outcome, which is when you roll a 4, out of 6 possible outcomes when you roll the die. So the probability is 1/6. Now, 2 standard dice are thrown. Determine the theoretical probability that the sum is a 4. Well, here's the 3 outcomes where we can roll a 4. So that's where we roll a 1 on the first die, 3 on the second, 2 and 2 on each die, or 3 on the first die and a 1 on the second die. So that's going to be 3 out of 36 possible outcomes, which is 1/12. A 7, well, we've got 6 possible outcomes there where we could roll a 7. So that is then 6 out of 36, which reduces to 1/6. An odd number is, so I'm going to erase this. So when we roll an odd number, so there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there is 18 possibilities where you roll an odd out of 36 possible outcomes, which reduces to 1/2. So half the dice roll should end in an odd, and half should end in an even, theoretically. Now, I've drawn out this tree diagram, and I'll just explain what it means. So if you select the first black sock first, then you could select the second black sock, or the third black sock, the white sock, the gray sock, first gray sock, or the second gray sock. So there's, for the first black sock, there's 5 possible outcomes if you select that one first. If you select the second black sock, well then on your second selection, you could select the first black sock, the third, etc. So there's going to be a total then for every one of the 6 socks there, because there is no replacement. And in the question it said that you selected one sock and then you selected another. It never said anything about putting it back, the first sock back. So when you figure out the number of outcomes, it's going to be a total of 30 possible outcomes. Now, in set notation, the sample set will be the first black sock, second black sock, first black sock, third black sock, and so forth until you get up to the second gray sock and the first gray sock. So it's a long process, and I won't go through all that. I won't make you do that again. Now, for where you select the 2 socks that are the same color. So, for example, you could select the first black sock and then the second black sock, or the first black sock and the third black sock, and so on. And so you'll notice I put an asterisk beside every one where there is a case where you could draw, pull out one color sock and then the second matching color sock. So out of the 30 possible outcomes, there are 8 favorable outcomes where you select a second sock the same color as the first one. And so that comes out to be 8 out of 30. And so this is actually the proper way of showing your notation. And so this reduces to 4 out of 15. So the probability of selecting the odds of selecting 2 colors the same when you pull randomly out of the drawer would be the probability of A to the probability that the complement of A. So in other words, it'll be 8 over 30 to 22 over 30, which is 8 to 22, which reduces to 4 to 11. So that would be the probability, the odds of selecting 2 socks the same is 4 to 11. All right, so on the next question, Noah is answering 4 true and false questions on a quiz, and he is guessing randomly. So I've drawn a tree diagram here to represent Noah's solution. So either he gets answer right or he gets the answer wrong by guessing. And it's a 50-50 chance, so equal probability of guessing right or wrong. So if he chooses right on the first, right on the second, right on the third, right on the fourth, then he gets 4 right. And then here, he would get 3 right, 1 wrong. Then he'd get here 3 right. Then here 2 right, 3 right, 2 right, then 2 right, and 1 right if he guesses the first one right and the next 3 wrong, and then 3 right, 2 right, 2 right, and 1 right, and 0 right. All right, so the first question was, what is the theoretical probability that it gets all 4 correct? Well, in this outcome, just like when you flip a coin 4 times, then there's going to be a total of 16 possible outcomes. And so you'll start to see this a little bit more quickly as time goes by. So the total number of outcomes is 16. And so the probability of 4 right will be the number of ways you could get 4 right, which is 1 out of the 16 possible outcomes. And for 2, the probability that he gets exactly 3 right, so that's going to be the probability of 3 right is the number of ways, so NA, the number of ways that he can get 3 right, over the total possible number of ways that he can guess on the test. And so there is 1, 2, 3, and 4 ways. So 1, 2, 3, 4 ways that he can get 3 right. And so that will give you 4 out of 16, which is 1/4. And for 3, ask you to find the number of ways that he gets fewer than 2 correct. So that means 1 or 0. So that's going to be 0, 1, 2, 3, 4, and 3, 4, and 5. So he either gets, there's 4 ways that he can get 1 right, and there's 1 way that he can get 0 right. So the probability of getting 0 or 1 right would be the number of ways that you can get no right or 1 right. And that's going to be then 5 out of 16. And 4th question was not all incorrect. Well, if you don't get them all incorrect, well, that means that the complementary event would be that you get them all incorrect. So then the probability is going to be then, so not all wrong will be equal to 1 minus the probability that you get them all wrong, which is going to be 1 out of 16. And so that's going to be then 15/16. In other words, there's only 1 way you can get all the questions wrong, and there are 15 other ways that you can get them at least 1 answer right. What is the probability of not rolling an 11 with a pair of dice? So if we go back to that chart, so you've got 2 ways that you can roll an 11. That means out of 36 possibilities, so that means that there's 34 ways that you could not roll an 11. So the probability of not an 11 would be the number of ways that we could roll an 11, which I said was 34 over 36, which reduces to 17 over 18. And the complementary event then would be the probability of rolling an 11, which, as we saw before, was 2 out of possible 36 outcomes, or you could just do it as 1 minus 17 out of 8 over 18, which is 1/18 or 2/36. So Emily estimates that the odds against Paul inviting her to the grad dance are 4-1. So what probability is Emily applying? Well, really, she's not measuring this. This is just basically subjective probability, because she's going to base that on past experience or what have you. What is the probability that Paul will ask Emily to the grad based on her estimate? Well, that means that she's got a 1 in 5 chance, because it's going to be 1/5 is him asking her to the dance, and not asking would be 4/5 out of a possible 5 outcomes. So the probability is going to be 20% that he'll ask her and 80% that he won't, based on what you should know about odds. And there's 1, 2, 3 ways that you could have 4 that we could have. 2 girls is 3 out of 8. So then Here we have 3 girls, so that's going to be 4. Where we have 3 girls or 2 girls. And then there's only one way that you could have a girl, then a boy, then a girl. So that's just one out of the 8 outcomes. So the probability is 1/8.